Let's go. Hello and welcome back, Cipheros, to Cipheros Mathematrix. Today we're gonna mega overview like a masterclass of rotated conics with its super tricks and maybe some useful tips that you can adapt, okay, and ace your exam. These things are quite complicated, sometimes tricky to understand, because these are conics. The conics are easy, but the thing is rotation. Seriously, the only difficult thing is getting that concentration to get the three conics rotated. On this topic, we talk about parabolas, ellipses, and hyperbolas, okay, as these are the only rotated conics, by the way. As circles actually don't matter how you rotate them, they are always the same. But the problems are with this. So let's get started. Basically, I want to do this the most intensive, crashy possible, but we have to understand first the stuff before applying them. So first is this general equation without factoring out and grouping the terms on a way we can identify the conic. We have this, okay, this form where there is x and y term all together multiplied, obviously, and its coefficient is just b, any coefficient, by the way. But the thing is that there is a b different from 0 that has an x and y multiplied, because obviously b is equal to 0, this doesn't exist. For example, we have a parabola. On this x and y plane, we have a parabola that has an equation like this form. It is rotated, okay? If it is not vertical or horizontal, we have that a parabola has this form. As you can imagine, this equation comes from the formal definition from ellipses, parabolas, and hyperbolas. We don't have just x minus h squared on these three conics. No, we have something just like this that we cannot group on a beautiful way. Now, the only thing that we can do is to work out this parabola or this conic in general with another axis where they are not rotated, okay, where they lie on parallelism with the y or x axis. But this is not the y or x axis, as we mostly, okay, on the problems we received this already defined. This is just an example. With this we can work out the parabolas if they are not rotated. On this lesson we'll call it u and b, as x prime and y prime are quite confusing and we will not get this harder than, in fact, actually than harder. It is very tricky, okay? It's just about concentration and to turn this equation into the UV system where this x and y or u and b doesn't exist. Now, if you want a picture about how this works, this is how we're gonna apply all these parabolas, okay, all these conics on every problem. We have the x and y that are already defined, and the u and b where this conic will be parallel to the u or b axis. So we have two planes where there is a relationship by an angle. On this case, u and b is rotated in comparison to x and y by an angle alpha. This angle must be between 0 degrees and 90 degrees or pi over 2, whichever you want to call it, as basically it's just changing the perspective and not rotating algorithmically. So let's start knowing the formula. How will we convert the x and y into u and b where the multiplication between u and b doesn't exist? Let's start by the definition. Any point B on x and y has these coordinates. They may be the same, they may not. The thing is that we are representing this with this coordinate, the horizontal and the vertical, while on the u and b, which is rotated by an angle of alpha, has these coordinates, u and b, which also may be the same, maybe not. The only difference is that obviously x and y are not equal to u and b, only if they are 0, by the way, as this rotation occurs from the origin. This x and y can also be expressed using trigonometry with trigonometric functions. Therefore, if r is the distance between the origin and the point, which basically is Pythagoras with the hypotenuse, we have this thing, okay? On x and y, as you can see, we have the angle alpha, and also between u and b there is an angle beta, which leaves the hypotenuse, okay, of this right angle triangle. You don't have to worry about this, but it's very obvious what we are referring to, okay, at this level with trigonometry. While on the u and b we have only this. Something really worthy to notice is that the distance is always the same. It doesn't matter what plane we are working with. As you can see, basically they share a distance, even if the components are different. Now these alpha and beta are not something pleasurable to see, therefore we're gonna expand this with this sum of angles formula. We know that there will be a point where r cos beta and r sin beta will be there, as these are also distributed, okay, on this expansion. Therefore, where there are this stuff, this u and b, there's r cos beta and r sin beta, we're gonna replace it by u and b and get our formula. I encourage you to try this out to really understand and see that this is not magic. Seriously, try this out. And then we're gonna get something like this. This is the only formula that we need to know about, and hopefully we are working just with the angle of rotation between the x and y and u and b planes. There is also a formula to pass from u and b to x and y, which is basically isolating this stuff, but do not worry about it. You need only this. Then maybe you will apply more steps, but it is worth it just to get confused with these formulas. Now to find the angle, we use this. There is also an explanation, but this is not interesting, or this is actually very easy to remember. We don't have to get into detail too much, as we are going to learn that with problems. As the presentation says, mostly there are two results, but pick the positive one. As we solve for tangent theta, you're gonna get two results. Pick the equivalence that is positive, or if not, you apply a inverse tangent to see what angle is positive. As remember, we are working with angles between 0 and 90 degrees, or pi over 2 not included. There is also a representation of this formula with the tangent of 2 theta, but we are going to use trigonometric identity. It is not worth it to memorize that we are using tangent of 2 theta, as we are just going to use this. B, A, and C are taken from the general form of the equation. Now, once we've solved for tangent, we're gonna do a trick, actually a definition to see what is cosine and sine of alpha. In this case, theta alpha, this is the same thing. Basically, I took this image, okay, from another thing, and basically we are working with an angle, okay? So basically, tangent is a relationship. We have a numerator and denominator. The denominator is the ratio of the x-axis, and the numerator is the ratio of the y-axis, as tangent is y over x. Therefore, we can apply this Pythagorean theorem, okay, to find the hypotenuse. In this case, we will call it h, and we can actually know what is the cosine and sine of theta or alpha, okay. So this is our cosine and sine of alpha. This is what we are working with, and then put these values onto the equation of transformation between the x and y and u and b. If A and C are the same, that stuff isn't defined. As division by 0 for now, it's not defined. This is data that we must memorize if we don't want to have problems. A is equal to C. The angle of rotation is 45 degrees. If it is 45 degrees, cosine and sine of alpha are the same thing. And then we can factor out, and this is our formula that we're going to get. Watch out very carefully this first formula, okay, this is x and y. Basically, we're gonna represent this just like this, okay, to do the transformations. And then where there is C and there is S, we apply the obtaining cosine and sine respectively. Why do we do that? Because if not, this will be a mess up. Seriously, my teachers and basically any professor that I've seen on YouTube or any place, they don't do that, okay. They basically go into the answer, but as this process is really tedious, using the already values of cosine and sine will be the U and C and B and S, and then when there is C and there is S, just set the respective values that we already know. As seriously, this is very easy to apply. Where there is X, we set this UC minus BS, and where there is Y, we set US plus BC. And this is pure algebra. Rather than working with the already values, okay, like a square root of 3 over 2 and those stuff, it's better to work out with this. And then factor out each term to get an equation where the coefficient of UB is 0. If it is not 0, there was something wrong, and we just have to fix that. And we're gonna get something like this. Okay, the order doesn't matter, this is addition. The only tricky thing is to turn out the equation into UV, as this is very tedious. But embrace it, seriously, that it will work, okay? And the next thing to know is that please do not use inverse tangent to find the angle. This representation of the same formula may lead us to think that we are just going to apply inverse tangent and then divided by 2 to find theta, and then we can just cosine and sine of this. Do not do that, as the angle will not be exact, okay? Or we're not going to get an exact value, and the cosine of theta and sine of theta we are not gonna get something beautiful, okay? We're gonna get like decimals, and we don't want to do that. The most important thing is working with cosine and sine of theta rather than the angle itself. First exercise, okay? This is very easy, and you don't solve it, it doesn't matter. This is just practice. You can take this from the theory and then apply the stuff for the next exercise. So let's identify the conic section of equation 3xy equal to 6. When there is no a and c, it's basically we'll just take this thing, okay, as a and c are the same. These are 0, okay? Just take this equation of rotation, as the angle is 45 degrees, cosine and sine of 45 degrees are the same, and then we factor out this. Now in this case, we divide everything by 3. This x and y is equal to 2. As we said, this happens where there is the x and y, we set the respective values. The square root of 2 divided by 2 times itself is just 1/2, and these u and v terms, okay, this is the differences, of course. Then we multiply everything by 2, and then we divide everything by 2 just to get an equation like this. Okay, what is this? Obviously an hyperbola. Now notice something, okay? Really notice something. If we set the x on the right side, we have an equation similar to 1 over x, which is a rational function. Any linear rational function is an hyperbola rotated by 45 degrees. Not by 45, okay, by 45 degrees. All this stuff, okay, any rational function that is linear, that doesn't have an exponent greater than 1, is just an hyperbola that has rotated by 45 degrees and has translations. Next, we are in up a lot. This is something I want to show you to find this trick that you see minus vs, etc. We are working with a harder problem to level up your skills. Consider the conic section with this equation where k is constant and the latus rectum is 4 units. Sorry for the typing there. We don't have actually much information, so this can be any conic, as all of these have latus rectums. If they tell us about that the center, it's basically an ellipse or an hyperbola, or if it tells us about that it has a vertex, it's basically a parabola, okay? But this can be any. So let's start solving a part. We're gonna apply everything that we've seen in the theory. As we can notice, the x and y are the same, the coefficients. This looks like a mess by the presentation, but I want to show you how to actually organize to not get confused on this process. Okay? Basically, I set a table, okay, or just an space apart where I solve individually for the x and y, the y squared, then the linear x and the linear y. Okay, in this case there is no linear x, so just let it as it is, and then I work out individually this, and not just putting all of this on a single line, as it's very readable to confuse us. So where there is the x, we set our equivalence, okay, on the first one is x squared, then just we solve on the x and y the same thing. On the y squared, the same thing, we set the y, and then as it is raised to the square, the same thing. Always considering the coefficients, by the way. As you can see before the brackets, I set the coefficients and then just do the stops. This is mostly practice rather than explanation, so I will let this, and then I can write on the next line basically all the factorization. As we can see, actually this is very ordered. On the u squared, we have this first part on each line on our chart is the coefficient of all the expression, therefore this is 1/2. On the x and y, this is minus 1/2, and then on this third line, this is 1/2. And the same thing with u and b. This is actually the most important part. The coefficient was we extract the u and b. On this first line, this is 1/2 of minus 2, this is minus 1, and then there is no here u and b. This is on the second part, therefore 1/2 of 2, this is 1. Then as you can see, this goes to 0 and the u and b is eliminated. We repeat this process with the b squared. This is almost at the end, therefore it has a coefficient of 1/2. Same thing with the b squared, okay, and then this negative just remains out. This minus 1/2 times minus 1 is plus 1/2. Okay. And on the third line, this is b squared 1/2. Then we set this part on the linear y. It can be solved very easily. And we do not forget the minus 2k. This is everything equal to 0, but I don't have a space. And just adding the coefficients, we finish out with a formula just like this. Well, actually, we can multiply everything by 2 and then complete these squares. This bracket throws times minus 2 squared, that is 4, 3 times minus 4. We have that this is minus 12 minus 36. Okay, that's 6 squared, and then we set just like this. Now we are invited to basically divide everything by 4k plus 48, and we said that this is an ellipse. Okay, it has a form of the ellipse. Now, which is great. A value is 4k plus 48, or a value divided by 3. Okay? Therefore, our a square on this ellipse is 4k plus 48. Okay, and knowing that the lactus rectum is equal to 4. Okay, applying this formula, our b square is 4k plus 48 divided by 3, and the a is obviously this math square root. Now, solving this equation, we get two values. Okay, the first one is minus 3, and the other one is minus 12. But consider this must be positive. Okay, as the problem also said in the lactus rectum. Okay, therefore it cannot be minus 12, as this minus 12 leads us to 0. Okay, therefore k is equal to minus 3. Now the second part is find the equation in the x and y system, and we don't have to actually use the minus 3 value. Okay, as we know, the focal axis is between the horizontal value. This is u, and the vertical value, this is b. By this locus, we know that this is 6, and to just apply this u and b points on the information formula, we get that the x and y center is 2 square root of 2 and 4 square root of 2. Now the focal axis on the u and b system should be something like this. Okay, the thing is that it is parallel to the u axis. Okay, therefore if it is parallel to the u axis, this focal line is equal to the value of the vertical part of the center. This line is b equal to 2. Now the tricky thing is that how do we apply that? How do we turn this into the x and y system? Now, knowing that we have to use the x and y variables, and u is repeated on the right side, you have to isolate u, and if both are equal to u, it means that these are also equal. Repeating the first equation, we have that u is equal to square root of 2 times x plus 2, and on the second equation is square root of 2 y minus 2, and then as just applying the properties, we have that y is equal to this. This is the equation on the x and y axis. And now the graph, if you want to know how is the graph, is something like this. This doesn't have to be very specific. It's just about sketching very approximately the center and the focal axis. So it could be something like this.